Good morning, Year 10s. Welcome to this video on simple factorising. Today we're going to go factorising that you probably will have covered in Year 9, and we're going to do it relatively quickly. Alright. Start off with, factorising is just reverse expanding, or splitting a term into its factors. So for example, we can factorise 80 by saying, well, 80 just is 40 times 2. That's what we could say, factorising 80. If we want to factor 80 into its prime factors, we have to go a little further. We have to reduce it to all of its primes. So we would say, well, 2 is prime, but we can split 40 into 20 and 2. And we can split 20 into 10 and 2, and 10 into 5 and 2. So the prime factors of 40, if you're interested, is 5 times 2 to the 1, 2, 3, 4. Cool, huh? Alright. Similarly, we'll often be using the term highest common factor. Hopefully you should know how to find the highest common factor of 24 and 40. It's 8. Alright, so simple factorising. Find the highest common factors, remove all the highest common factors and the common variables outside of brackets. So what that looks like here is to think about, well, what are the highest common factors of 6x and 20? I can think of 6x as 2 times 3x. There's meant to be a times in there. And I can think of 20 as 2 times 10. Note here how I've highlighted the highest common factor of both, which means we can remove that, and that leaves us with 3x plus 10. That's what's called factorising, taking out something that's common to both. Alright. Here, we want to take out the highest common factor. Note the highest common factor here is actually 16. So really, we can think of this as minus 16 times 1 lots of x and y. Minus 16 times 3 lots of x and x. So what I've done is just break everything up. We have minus 16 and 1, x, y, minus 16, 3, x. And I'm going to take out what's common to both. What's common to both is that x, and the minus 16. And typically when we're factorising, we take out the negatives. So negative 16x, that's the x we've removed. And what we're left with is 1y, so we just write y, and then a 3 and an x. So positive 3 and an x. So we factorise it by splitting the numbers up and taking out everything that's common to both. Note that you don't actually have to write this step here. That step is optional. If you're comfortable to go without it, fantastic. But make sure you're getting it right. I'll just show the step. 7ab, that's pretty well split, minus 4 times 7abb. What's common to both is a 7, an a and a b, a 7, an a and a b. We can think about that in the start there as 1 times 7ab. So if we're taking out 7ab, what we're left with is that 1, and it's important we include it there. And then we're left with a minus 4 and a b. Note, if you want to check whether you're getting it right, you can expand this back, and you should get back where you started. So to expand this back, we would do 7ab times 1 is 7ab. 7ab times minus 4b, well, 7 times minus 4 is minus 28. The a stays because it combines with nothing, but the b combines with the other b to make a b squared, and we get back to there. So we should be comfortable that when we factorise, we can always go back to where we started. Now the one on the right here looks a bit odd, and I guess it's an advanced one, in that the common factor to remove from both is, well, we can think about this here as 2 times 3 times m plus 5, minus 2 times x times m plus 5. What's common to both is this 2, and oddly enough, this m plus 5 can come out as well. So we can remove 2 m plus 5, and what we're left with inside the brackets is 3m take x. Right. Now I know that looks super odd, but remember this bracket here is just the equivalent of that one there, and this front term is what was in both. There was a 2n plus 5 in both, we took it out and had another pair of brackets. Now, this little strategy leads to something called grouping. Sometimes you'll have 4 terms and doesn't appear to be a common factor with any of them. So take this one on the right, sorry, on the left. It doesn't look like there's anything common to all of them. There's not an x in all of them, there's not a 4 in all of them. So what we can do is factorize by grouping them in half. We can say, well, let's just look at this half and that half. Apologies, the line in the wrong spot. If we look at this half, well, what's common to the left-hand half? Well, x can come out of both. So if we took the x out of both, we'd be left with x take a. What's common here is we can take a minus 4 out. So remember how I said we remove the minuses? If we took out minus 4, we'd be left with x. And here's the odd one. We can think of this as minus 1 times minus 4 times a. The reason we're doing minus 1 times minus 4 is because that gets us positive 4. Now, if we take out the minus 4 to belong in the front, we're left with minus 1. So we're left with minus 1 lot of x, minus 1 lot of a. Because that's the minus 1 times a brings us in minus a. Now note what we have here. What we have is this common factor of x take a, like we had up here. So what we're going to do is we're going to remove that common factor, x take a, and what we're left with is x take 4, which is a really cool way of factorizing. And it's the only way, really, we can factorize something with 3 variables in it. Alright? The hard thing is that negative. And I chose another example with a negative here. So, highest common factor on the left is 3x. And we're left with x take 2a on the inside. Note how I've sort of skipped that intermediate step. And then we're going to take out a minus 7. If we take out minus 7, what we're left with is just the x take 2a here. Because when you have minus 7 times minus 2a, that gets you positive 14a. Alright, now note we have x take 2a as a common factor, so we can take that out. And what we're left with is 3x take 7. Done. Alright, I know that video went for a little bit, but simple factorizing, and then factorizing by grouping. Please take the notes, and I will see you in lesson tomorrow.